All right, here's a helper video for the packet using derivatives to describe functions. We got a pretty good start on this in third period, but fourth period I handed it to you and pushed you out the door. So sorry about that. So first of all, I want you to use 3 different colors and try to be consistent throughout the whole packet. 1 color for the function, 1 color for the derivative, and another color for the second derivative. So then you're going to find the first and second derivative of your function. So the derivative of x squared would be 2x. And then find the derivative of that to get your second derivative. The derivative of 2x would be 2. And then you're going to graph all 3 functions on your graph. Okay, in order to do that, it's fine to use Desmos. In fact, I encourage you to use Desmos, and I should have opened up Desmos before I got started here. Here comes my Desmos. I actually prefer to do it on the computer, but I can't show you my computer screen at the same time that I'm showing you this. So here we go. So I would put in f. Let's see where my parentheses. See, I don't even know how to do it on here. F of x equals x squared. Okay, then for the next one, you don't even have to type in the whole equation. You can just do f, oops, sorry, where am I? Where's my prime? Go back. Prime, f prime, oh my god, I'm so slow at this. Sorry, I'm only going to do this one time. So you can just do that. You don't even have to type in, oh, you can't see it. There it is. So you don't even have to type in equals 2x. It'll do it automatically for you. Okay, and so then you're going to go ahead and plot it on here. So I can see that they're giving me points here and here, and then I can graph that on here. Okay, and I just lost my ruler. Shoot, I wanted to make this look all nice and pretty, but I've lost my ruler. Oh, here we go, student ID. Okay, so then I can graph my first derivative. And of course, I want to graph my original function. Again, you can just take this straight off of Desmos. If you know how to do it by hand, then by all means do it by hand. And my second derivative, that's y equals 2. That would be like this. And then color code it. So I said orange was the original function, and pink was my first derivative, and yellow is my second derivative. All right, so then after you've done that for each problem, you're going to be answering some questions. So this particular question, why is the second derivative a horizontal line? Why does that make sense? So think about what we talked about today in class. What does a derivative tell you about a function? So think about that, what we know about the relationship between a function and its derivative in order to try and answer these questions. Okay? So you're going to work your way through this, and I wanted to give you some additional language to help you refer to things in here. So for example, where is it? Describe the shape. So when you're asked to describe the shape of things, I wanted to give you some extra vocabulary. So back to page 1. Notice my parabola here. This parabola is facing up, whereas the next one, see it's negative x squared, it's going to be facing down. So I wanted to give you some new vocabulary to describe that. This one here, a way of describing this is to say it is concave up. Concave up. Concave means it's like got a dent in it, and the up, it's facing up. Whereas this one, when you do negative x squared, if you graph that, it's going to go like this. And when you describe that shape, this shape would be concave down. So this little bit of vocabulary, concave, the concavity, is going to help with some of the descriptions of the shape and what's going on each of these graphs that you're making. So this is some vocabulary you should be trying to use if possible. So this is concave down, this is concave up, that shape is what we're talking about. Okay, concave up and versus concave down. Okay, so that's a little hint to help you with some of your descriptions of the shapes of the functions and the connections that you're going to make between them. So hopefully that's enough to get you through this. If you're not sure, like here on a question, what do you think the second derivative tells you about f of x? If you're not sure, just take a wild guess. And then as you work through this, hopefully you'll figure it out. So the goal on this worksheet is to figure out what does the second derivative tell you about the function. That's what we're trying to figure out. Okay, so that's the main goal here. What does the second derivative tell us about the function? In class today, we talked a lot about what does the first derivative tell you about the function. The first derivative helps us find the maximum and minimum values of the function. It also tells us the slope of the function at a given point and along different intervals. So if the y value of the derivative is positive, then in that same interval, the function is going to have a positive slope. Okay, if the y values of the derivative are positive, the function is going to have a positive slope along that same interval. Okay, so all those good things we talked about in class today, and they should be in your notebook because that was part of our warm-up. All right, so you're gonna think about those ideas and how does that relate to the second function. It's going to introduce some new information about the function. The second derivative actually tells us some important information about the function. So that's the goal, is to figure out what is it? What is it telling us? All right, good luck and use that new vocabulary.